Benchmark. I'm watching, today's April 29th, 2022. I'm watching a show called Mission Impossible that they had on, I think sometime last week, and I finally got around to watching it. And it has this teacher who shows what a simple circuit is for electricity. In the education program I was exposed to, held captivated in New York, I never even got to that level of watching and learning how the electrical circuit works. I think they had a field trip once in elementary school with a light bulb and two wires. But it was not something that was reinforceable, and it was not something brought into our educational training of any kind. I don't know why. I'm not clear as to whether my children were able to learn what an electrical circuit looks like. Simple circuit, not coding and all this other crazy stuff, just simple circuit. However, I know through STEM, there are other children that have been exposed to it and actually are trained in it and have some career pathway to success that they've already planned out for these children in some disgusting whatever humans are doing that we've been left out of.
Mentors and heroes to help make our world a better place. The future is here. The mission unstoppable. See, the enemies are famous for being home.
Team on CBS.
In this next segment, teacher and maker Kelly Taylor is going to hook us up by showing us how to make a circuit using unconventional materials. Take a look. Lots of kids dream of being the next great engineer or scientist. But did you know learning how...
Actually, in this area, in this day and age, unless their parents, grandparents, or they have some family member or exposure into this isn't even in on their radar as a possibility to even reach for or to speak about.
Learning how to design spacecraft begins with normal crafts? To find out how, today we're talking to Dr. Kelly Taylor, an elementary school teacher in Boise, Idaho.
The thing that I love most about my job are the students. I get to share my passion with them, passion for making, passion for learning, and then they get to share their passions with me. So
She's about Linda's age, my mom. She got a doctorate, maybe some graduate. I don't even know how doctorates, master's, or graduate or higher education works. But she's in, what did they say, Ohio? Somewhere Midwest. In the Northeast, within the 13 colony corridor. Linda didn't even have a master's, college, or anything, any plan built or set for her. There was no guidance whatsoever. It was hairdressing school, and that was the tops of their meager attempt at making her useful as a human.
each year, I meet a new group of people that get to inspire me, and I continue to learn from them throughout the years.
Dr. Taylor is going to show us how becoming a scientist, artist, or engineer starts with making.
So have you ever made a picture, written a story, created some type of art, or even tried to make a robot of your own? Then you are a maker. Making encourages problem solving, critical thinking, and of course, communication.
Makers can create with almost anything, from rubber bands and foam to good old-fashioned construction paper. Using simple supplies like this, Dr. Taylor teaches her students the basics of electrical engineering, bringing art and
The basics of electrical engineering are not even taught to Linda, Lou, and myself.
science together with paper circuits.
A circuit is where you have energy flowing from a power source, battery, outlet, to something that's drawing a load, maybe a light bulb or television, whatever the case may be. Today, we're going to start with just some paper, some copper tape. We need a power source, so we're going to have a battery, and then we're going to use some sticker lights.
She starts by planning out the layout of her simple circuit. Next, she lays out the copper tape, carefully bending it at the corners.
We can't tear or cut the copper tape, otherwise we open our circuit and the energy cannot flow.
Leaving gaps for the battery and sticker light, Dr. Taylor smooths the tape down with a pencil, attaches the conductive light to the copper on the circuit, and test attaches the battery to see if it all works.
Ooh, success! All right.
A successful test means a complete simple circuit, with current flowing out from the positive terminal of the battery, through the copper into the light and back to the battery. Making a parallel circuit is similar, with Dr. Taylor again planning, taping, and testing.
So I haven't learned simple circuit in the education program that I was exposed to while in the whatever I was moved between field trip, but not something that's recallable. I know there was a light bulb and there was touching of a wire to a battery. That was it. But there was no like long lasting educational connect for that. And then this one's a power, so simple circuit wasn't explained. Parallel circuit certainly wasn't explained either.
Electrons are flowing out of the positive pathway, and then at each light, they're coming back to the negative terminal of the battery. When I bring making into the classroom, my students aren't just working on science or math or engineering. They're putting it all together and maybe even using computer coding.
One place Dr. Taylor looks to for inspiration is the path.
And this garbage and nonsense does not help. There's no baseline. I have nothing to sit to interact and pass on. And nobody has, like, I wasn't born with a list of just how out of control this area would get with technology to know where to reach for resources and access, or how to help my children, because there's some regressive ability within some time dilation, whatever, which is in a zoning and districting issue that's even more scary.
Pathfinders Online Institute.
These resources mean nothing if there's not an educator who's already educated on the process and how to pass the process along for efficacy. Efficiency.
From our sponsor, Infosys Foundation USA.
You can access live events, you can find computer science classes for different age groups, and there's even resources for students to access with online challenges, design thinking, inventing.
Dr. Taylor's students take what they've learned about paper circuits to make their own art and science projects.
So we're using our simple circuits to...
And here's the thing, even if you went to that website and took all of the classes for visualization to learn and absorb as much as you can you actually make money and use it in this world? They haven't allowed me thus far.
To create some thank you cards featuring family pets and loved ones, a giant card, a Morse code device, wearable dragon, this 3D globe that you can then light with a circuit from within. You can also code circuits through robotics and other computer devices. So once you...
Now, this piece I find really interesting because this is something like I used to do as a kid just naturally that I used to absolutely love, which was like life science, like just going out and observing life and, not really having anybody to teach me anything more than just what I could see with my eyes. Not much has changed. But what happens is they then take the live sample of a living organism. It's life. They go into the lab, and they're not the first ones to do it. There's been generations before them that have taken samples out of the ocean, have gone and performed the exact same experiment, which is leaving them in their habitat controlled environment where they live happily, or if they raise the temperature and then they get bleached. But yet they're still they already know if you raise the temperature, the end of the story, spoiler alert, it gets bleached. So what I don't understand is why do you have all of these graduate students, researchers, and whatnot continuously entering this most disgusting educational system where they perform the exact same experiments, but yet you still have bleaching in the ocean. They already know so that means that humans have already proven their educational system is not worth teaching them because they've taken all of their education and done nothing with it to prevent the bleaching of the coral reefs in the oceans.
Species. And inside of a clump, they're even the same clone of one another.
That's how they reproduce? They just make an exact copy of each other?
Yes.
That's amazing.
They only clump together with the ones that are the same as them.
So they're very cliquey. Anemones.
Like, this is great, this is a lot of fun, but what do they do with the education? I was never offered this level of education or to be involved in a process to try to get stuff done. I was left out of this for I don't know whose agenda.
Do clicks.
Very clicky. These anemones, they're really cool in a lot of ways.
Yeah.
The anemone actually has algae that lives inside of them. So it's two organisms living together, the same relationships, and that happens with corals. So I'm trying to figure out how did these guys do it, and can we apply that and help corals? What I really want to find out is why can these guys survive here even though it's such a stressful, extreme environment?
To collect today's sample, Maria uses a tiny spatula to gently separate an anemone from the rock. While he gets settled,
Oh, and they named it Steve.
we head to Maria's lab,
Even
where she
Steven
places him
and
in
all.
his new home, a little cup. While he gets settled, Maria shows me his new neighbors, anemones she's already collected.
Because they are clones, I can sample two of the same clone, genetically identical, put one in a tank that's going to be their normal temperature, normal conditions, put the other one in another tank, which I will slowly heat up the temperature until their relationship with algae begins to break down. Normally, when they're happy, the algae can photosynthesize like a plant, and it produces sugar, which they give to the anemone. So the anemone just gives them a nice place to live, and the algae gives it food. But when we heat them up, the anemone actually loses that algae, loses its color, and turns white, which is called bleaching.
Once they are heated enough that they start to bleach, Maria takes the anemones out to examine and count the algae in their tentacles.
They're like white on the tips, but the rest of the tentacle is brown, and you can kind of see the little cells that are in there right
Those
now.
are the algae cells.
Exactly.
With confirmed algae in the tentacles, Maria's ready to take an even closer look under the microscope.
Looking good, looking good. This guy was happy.
Hopefully understanding why these algae and their anemones survive under stress will open up new ways.
Now, they have blue lab coats. I had a white lab coat.
Maria's ready to take an even closer look.
I don't know what that means. It's star 1978, star 8378, Nicole, Cattaruzza. Its Earth, solar system, Milky Way, universe, galaxy is broken, and its Bayside station, Bayside, New York, 11361.